Welcome back, guys. Picking up from where we left off last video, let's get the player to figure out its layer depth dynamically and constrain the player's movement to the level bounds. So first things first, let's work on getting that layer depth working. Okay, so last video I said don't worry about too much about this 422 and 128. Well, now we are going to worry about it and figure out what those values are. So 422 is from the top of the screen down here. We've got 422 where the tip of the fingers are, the corner of where the ground meets the wall, and 128 pixels down from that is going to take us, I think it's this one, or is it that one? Pretty sure it's that one there. Let's go that one there and just pretend it is. That one there is 550 pixels from the top down. So our play area is 128 pixels big, or tall. So into our whiteboard, and let's take a look-see at how we can use this to our advantage. Across there, just pretending this is our play area. So 0 there, down to 422, the top of our play area. A range of 128 is going to give us 550. So we've got our layer depth section for the level set up, and our layer depth section for the play area was 0.6 down to 0.4, which gives us a range of 0.2. So what we need to do is take our actor's position anywhere between 422 and 550, get it into a range of 128, figure out what percentage it is of that range, and then convert that percentage over to a value between 0.4 and 0.6. And we do that by timesing it by our new range of 0.2 and then adding on the minimum, which gives us our new layer depth value, a value between 0.4 and 0.6. So let's go into Visual Studio and code that out. First thing we're going to need for our actor is it needs to know what level it's in. So we'll say level in level, if I can type it properly. Let's add in here public level in level. Why public? Because our actor also needs to, our player also needs to check it out as well. So this dot in level equals to in level that we just passed in. And down here, let's make a new method, public void get layer depth. What did we have to do first? We had to get the actor's position as a percentage of the total play area. And we can do that with checking out some values. Our minimum value was in level.playbounds.top. Our maximum value, int max, equal to in level.playbounds.bottom. So there's our 550. Our range, int range, equal to maximum minus minimum. So we'll have a positive 128. And now our percentage, our float percent, equals to, because we're dealing with integers, we have to convert them over to, or cast them over to floats so that we can get a float as our end result. So we'll say this float this dot position dot y minus float minimum divided by the float of our range. There we go. Bit of a problem though, we've got to divide the y there, so we need to do this bit here first. We need to make sure we use the subtraction, which is good old BODMAS rules. Now we need to convert our percentage, convert percent to a value of layer depth range. Now our play area, layer depth section, was 0.4 was our front to 0.6, which was our back, because we were using our sprite sort mode when we originally called sprite_batch.begin back in game 1 is back to front, so back to the front, which gives us a range of 0.2f. There we go. And how do we do that? Well, we can say this dot layer depth equals percentage times our new range 0.2f, plussing on our minimum value of what our front is. So our minimum value is 0.4, which is 0.4f done. There we go. Okay, so now let's layer depth needs to be public as well. I just know that there needs to be that for later, so I'm just going to quickly do that before I forget. Layer depth and public. Okay, and check out what's happening here. Let's go into our player and quickly take in a level in the constructor, pass it back down for the actors constructor. Bit of a problem, our player is not taking in a level to start off with. Well, first thing is let's just clean up this. We don't want it in the center of the screen because that's going to be outside our play area. We can set it to 400 for sure, but we need something more than 422. Let's set it to, let's say, 457. Now we need to take in a level, this level that we're working on, and now we need to take in our player index, which lines all those up nicely. Okay, then we add it, but look at this, our actors constructor calls, well, let's make it calls get layer depth, which uses its levels play bounds. But we're making the constructor do that before the play bounds have been defined, so we need to change this bit here as well. Take this above level 1, backgrounds, and we'll say define play bounds. Alrighty, in fact, I don't like it there. Let's put it below where we set up the backgrounds. That works for me. Okay, that's that done. Our player, what does it need to have happen on it? Any changes? Well, I guess we can, while we're here, set up our constraining it to the screen. So don't let the player go off the screen or out of play bounds. And we can do, let's work on the left and right first. So if this dot position dot x is less than, our camera's position is at the center of the screen or the center of the viewport or the center of the application, and then we know that our left hand side of it is 400 pixels away from game 1 dot screen width divided by 2, so we can say camera dot position dot x minus game 1 dot screen width divided by 2. And if we are outside that, let's just set it to that value. Now we'll do the same for the right. Except for right, we check is it bigger than, and we plus on the 400. Now for our top and bottom of the play arrow, we can do the same kind of thing. If this dot position dot y is less than, so we're checking for up the screen, the top, which is in level dot play bounds dot top. And if we are outside of our play bounds, we'll just set it so we're inside it. And we'll do the same for the bottom. But our bottom needs to check if we're bigger than. There we go. And we'll now set it to, say, get layer depth. So after we've moved, we get our actors, or our players, new layer depth, which is still an actor. And what else do we need to do? Let's go into our game manager. If we run this right now, we don't have anything to check it against. It's not really going to be noticeable if the layer depth is actually working. So let's go to our classes and add in a new one and add in an enemy. Getting rid of that guy and saying using Microsoft.xna.framework and also using the graphics, inheriting from actor, and a constructor public enemy takes in a vector2 for position, and it takes in a level for in level, and it passes them straight back down to base. Position in level. May as well set up our overriding update method, but tell it not to bother with the actors base one because it does nothing either. Public override draw. This one we're not going to call the bases draw, because if we do that, our bit of a problem is we'd be drawing more white boxes, and if we're drawing white boxes trying to check one which one's behind the other when they're all the same color, you can't really do it. So let's go back into our actors draw, steal these, slap it in there. Sprite 1 single pixel. Yep, it doesn't like draw area because I didn't make that one public. I'm not going to bother doing that because we're going to be deleting it soon anyway. New rectangle. Let's just set it up manually. 0, 0, 40, 40. Using the same one. Color.white is the issue. Let's make them red just because they're evil. And that sets all those up. Vector 2.0, drawing from the top left corner. Not flipping it around, not yet to notice it did anyway, using the camera's position. Sweet, that's everything we need there. Let's save that. Now we need to actually add them onto the screen or into the level. Enemy, enemy, enemy equal to new, enemy. Where should we put these? New vector 2. We know we need them to be on the screen somewhere, so let's set it to 556 and 458, so it's higher than 422, and our level is the same level we're looking at before. And we say level.actors.add the enemy straight to there as well. Whoops, wrong one. Semicolon. And this guy here, we'll set it a bit more over to the right, so maybe 600. And a little bit lower, 527. Adding it in as well. Rightio, let's press, if I can speak properly, let's press play. There we go, got it out eventually. Pressing that, running our application. Where did I put my controller? How did you make it to the floor? Anyway, title screen, begin game, that text is massive. We've got to do something about that. In here, we're stuck on the constraint to the play area. That's good. Can't go up, can't go down, can't go off the left-hand side. Great. But watch this, bit of a problem. We're drawn on top of our enemies, and if we go below them, we're drawn below them. That's not quite right. It doesn't look right. It's supposed to go the other way. If we're up here, we're supposed to be behind the other guys because we're further back in the background. So, or we're further away from the camera, so we should be drawn behind the red enemies. So, ending that one. Let's go into our player and make it draw what its layer depth is. Tell me your layer depth. sb.drawString game1.font small. What text are we going to be saying? Layer depth plus this dot layer depth dot toString. We need a position, new vector 2 2020. Just putting in the top left corner. Color, I want it to be black so I can actually see it over the different multicolored background we've got. Let's use the 0 rotation, vector2.origin is vector2.0, scale 1f, sprite effects none, and we'll let this one go off the screen just for the moment. We know that 1 is our back and 0 is our front, so we'll set this to 0f so it's drawn on top of everything. And now let's run the application and see what we get. Up the top is 0.4. Down the bottom is 0.6, but 0.6 is further in the background and 0.4 is closer to the front. So we've got a bit of a problem and we need to flip those around somehow. So let's go back into our actors get layer depth method and check out how we can do that. Our minimum is the top, our maximum is the bottom. We need to flip that around. So let's change this one to minimum minus maximum. But that's going to give us a negative value. Well, let's make this one here a maximum. And just give it a run and watch what happens. Going to the top of our play area once it actually runs for me. There it goes. Start, begin game, up the top, 0.6, down the bottom, 0.4. Ooh, funky. It's going to work this time. So we go behind the red and we can come back and down and we're in front of it. Hey, let's walk circles around our red enemy. And down the other one as well. Working sweet. Now if we go through them, it'll boop, change around just like we want it to. Perfect. Just what we want. But how is this working? 0.6 to 0.4. Let's put a breakpoint in here. Right on percent. Right, put one there. There we go. Running. Go, go. Give me a breakpoint. What have we got? Our range is negative 128. Now our position is 457 minus our maximum is negative 93. So we've got a negative and we're dividing a negative by a negative 128. So what that does is it gives us a negative, a positive, because we're negative divided by a negative is a positive, 0.726. Now we'll go down to the next one, and what do we get? Percent times 0.2 is 145, plus our 0.4 minimum gives us 545. How does this work? Let's go into our whiteboard and take a look-see. So here we are on the whiteboard. If we just pretend with me like while I do this, if we do 550 minus 422, so let's put our bigger value down here, or up here, 550, 422 minus 550 gives us negative 128. Basically, we're reversing this side here, but we want over here to stay the same. We want 0.6 for the background and 0.4 for the bottom. So we're shifting this entire one up. We're just grabbing it there and just moving that up. But on this side what we've done is by making it negative, we've flipped it around. We've just kind of taken this guy and where can I put it here? Flip it, rotate it around. What that does is a negative value into a percentage gives us the other way. So it's basically going like this, but then mishmashing it. Instead, if you wanted to, you could actually give it the same one and minus 1. That would give you the same result. So let's go back into our side-scrolling beat 'em up and just test that out. If we change this one here from max and min and left this guy here as min, and then we said percent equals 1 minus percent, or 1f minus percent, we wouldn't have to change our minimum and our max minus min. We're just reversing what our percentage is. We're converting it around to the other way, pretending it's reversed. Pressing play. We're not pretending it's reversed, we are reversing it. And press play. Come on, load up. Any second now. Don't make me look bad in front of anybody. God, come on. There it goes. Begin game. Does the same thing. 0.6, 0.4. So we're behind, we're in front, we're behind, we're in front. I just wanted to show you another way of doing it, which was min, max, converting you to max. Saving you a line of code. Pressing play. Hey, it's another way to reverse that percentage. More tools you've got under your belt, the better. Nice. That works. That's everything we needed done in this video, guys. So I reckon it's about time we ended off this phase. Phase 2 now complete. What was phase 3? Let's go back into implementation plan. Phase 2, creating the larger levels, setting up the foregrounds and the backgrounds and the camera. Done. Next one, player setup. Oh, cool. We get to look at the sprite sheet and make it walk and jump and stand there and idle and get it funkadelically working. I'm going to call this one a wrap up, guys. See you in the next video where we go over the implementation plan for phase 3. See you there.